Here are two of the problems from the very beginning of the test review, and we haven't looked at these in a little while. 1A, it says just to write down the format of the partial fraction decomposition, but not to actually find the values of the capital letter variables. So all we need to do is just write down, if it says don't solve for them, just write down what the format looks like with capital letters. So the main thing is to look at the denominator. It's already factored for us. So I need a fraction for each of the factors. And if there's a double factor like x squared, I'll need to use it twice. I'll have to use it whenever there's a power on a factor. I'll have to use all the powers of that factor. So that means I would have, for instance, a over x squared plus b over x. Since there's an x squared, I need both of the powers. Actually, it doesn't matter which order I write those in. I could put x underneath that and x squared underneath that. But the reason that I put just the letter a and just the letter b on top is that I'm interested, if I have a power on a factor, I'm only interested in what's inside of it. It has to be a power on the whole factor. Looking ahead, when I get to this one, x squared plus 3, that's the whole factor. There's no power on the outside, so I'll treat that one differently. Since there's a power on the outside of this one, I only look at what's inside, that's the x, and what's inside the x, and then that gives me 1 degree down, so just a constant instead of a times x. Then I've got the x plus 2, so sure enough, there's another one. Again, just a constant c over x plus 2. And that's the partial fraction format. Then you'd go find out what a, b, and c are, but it says not to. So I'll do that on the next problem. This one it says to actually find the constants as well. Again, it's all factored for me. So the format is going to be a over x minus 1. And now this factor, I guess I should look to see if I can factor it anymore, but I can't over the real numbers. X squared plus 3 doesn't factor unless you use imaginaries. So if you look at the graph of x squared plus 3, it never touches the real axis, the x-axis. So I have to keep it. It's irreducible. And now that is a denominator x squared plus 3 of degree 2. So I do need a bx plus c as the numerator there. It's 1 degree down. All right, now I'll try and find the values of a, b, and c. Well, the trick here is that I just have an equation with fractions on the left and the right, and two things work together. One is that I need to add these fractions, so I need a common denominator. But the common denominator is already visible. It's x minus 1 times x squared plus 3. So I just need to get that common denominator by multiplying the first fraction by x squared plus 3 over x squared plus 3, and the second fraction by x minus 1 over x minus 1. And then I'll have two big fractions with the same denominator, and all I need to do is set their numerators equal. If it's a short enough one, I can figure out what the numerators are and just go ahead and set them equal. It'll be 7x over there. This one will be a times x squared plus 3. And this one will be bx plus c, all times x minus 1. So that's an equation of the numerators after having added those two fractions together on the right-hand side. And so I didn't show the denominators, I was skipping a bit. You don't need to, though. I'll make a note of it, though. The denominators are all x minus 1 times x squared plus 3. So that's why I could just set the two numerators equal to each other. Then I can collect some like terms, expand and figure out what a, b, and c are. So I need to multiply through. I have x squared plus 3a, and then I need to FOIL this one. I have bx squared plus cx minus bx and minus c. Check that FOIL work. Plus cx minus bx minus c. I need to collect all the like terms. So this is just mostly just doing a little bit of simplifying work on the right hand side. So I have a plus b times x squared. I have c minus b times x. Let's see, I've taken care of the x squared parts, and I took care of the x term, and then I have just 3a minus c. That will be the constant term. All right, now I can compare left to right, and I can set equal the coefficients of like powers. So for x squared, there is no x squared over here. So I get a plus b equals 0. There's the coefficient on the left-hand side is 0. For c minus b, that's the one that's going to be equal to 7. And then at the end, there is no constant coefficient on the left, so 3a minus c will be equal to 0. So those are the three equations that I get from setting the three coefficients of like powers. And now I need to combine them in order to figure out some of these values. Let's see. They all have 2 of the letters. So we'll have to end up doing some substitution probably. If I add the first 2 of those together, I'll get the b's to cancel out, and I'll see that a plus c is equal to 7. That's interesting. Might as well try that. So I get a plus c equals 7 there, because b minus b is 0. So then I notice I could write that one underneath this one. A plus c equals 7. I just moved it over there to see it better. And adding those 2 together, I get 4a equals 7. Because now the minus c and the c canceled out. That's a minus. So now I have a. A is equal to 7/4. And I should be able to find a few others pretty quickly. A plus b is equal to 0. So that means b has to be negative a. So negative 7/4. And c minus b equals 7. So I'll write, let's see what I've got so far. 7/4. Negative 7/4 for b, and I have c minus negative 7/4 equals 7. So I have c plus 7/4 equals 7. Or you could just subtract that from both sides and say c equals 7 minus 7/4. And that would be, you could get it all in one fraction or on a calculator. 28/4 minus 7/4 are equal 21/4. Those fractions are kind of large, but they don't simplify any more than that. And so now I know that I could fill those three back in for A, B, and C in the original. And I believe I did that at least to show you in the answer for the answer key. But there's the work to see where I got them.